Hello students, hope you're doing well. In this video, we are going to look at the last concepts or the remaining concepts of waves and sound waves. The concepts that we are going to look into are Doppler effect. We'll try to understand what is Doppler effect and then try get expressions for various situations and beats. Doppler effect. Now, what is Doppler effect? Doppler effect is the phenomena of apparent change in frequency due to relative motion between source and observer. So what is so we can say it is the master formula of Doppler effect. It says apparent frequency, I'll say f dash, or I'll say f equal to f naught into v plus or minus vo by v minus or plus vs. This is the formula. Now here v is speed of sound, vo is speed of observer, vs is speed of source, right? So now let's look at various situations. First, I'll assume that source is at rest and I look at various situations based on this. Source rest, then if observer moving towards source, now if observer is moving towards source, what is happening? They're coming closer, so frequency should increase. So in that case, so if source is rest, I can write vs equal to 0. I'll use a different color, so I can say f equal to f naught into, because the frequency increases, velocity of speed of sound plus speed of observer by v. This would give the apparent frequency. Now let me look at other situation. Again, source is at rest, observer moving away from source. So this is first situation, this is second situation. Now if observer is moving away from the source, this motion is resulting in uh, source and observer moving away from each other. So there should be a decrease in frequency. So frequency is given by f equal to f naught into v minus vo by v. So these are the cases of source at rest. Now let's look at case of observer at rest. So we have observer at rest. So if observer is at rest, vo equal to 0. Then the two cases that we can have is one, source moving towards observer. So if source moves towards observer, now this motion is resulting in source and observer moving closer to each other. So that means there should be an increase in frequency. So apparent frequency is given by f naught into v by v minus vs. Why minus vs? Because if the denominator value decreases, the net value increases. Similarly, source moving away. So source moving away. So if source is moving away, frequency has to decrease. So f equal to f naught by v plus vs, because if the net value has to decrease, denominator has to increase. So these are the cases where either source is at rest or observer is at rest. These are the four cases. After that, let's look at the other situations where both source and observer are moving. Now let me take one example where source and observer are moving. First case is source and observer moving towards each other. So they're moving towards each other. So if they're moving towards each other, then what is happening? Due to motion of both source and observer, the separation between them is decreasing. So both motions should result in increase in frequency. So the apparent frequency is given by F naught into V plus VO, increase in numerator, and V minus Vs. So this would be the expression for apparent frequency when source and observer both are moving towards each other. Now second case, source and observer moving away from each other. So if source and observer are moving away from each other, then this motion, that is motion of source as well as observer, results in the separation between source and observer increasing. So because the separation is increasing, the apparent frequency should be less than actual frequency. So F equal to, I can write F naught into V minus VO. Due to motion of observer it is decreasing, by V plus Vs. Due to motion of source also it is decreasing. Now the next case, I can say source following observer. Now source following observer means observer is trying to go away and source is trying to catch up with observer. So motion of observer is trying to increase the separation and motion of source is trying to decrease the separation. So I can say apparent frequency is F naught into motion of observer is increasing the separation, so decrease in frequency. Motion of source is decreasing the separation, so increase in frequency. So minus Vx. So increase in frequency. So here motion of source results in increase in frequency, so the denominator decreases, and motion of observer results in decrease in frequency, so the numerator decreases. Now the final case, I can say observer following source. So if observer is following source, then what would happen? So if observer is following source, then motion of observer is trying to decrease the separation between source and observer, and motion of source is trying to increase the separation between source and observer. So motion of source would result in decrease in frequency and motion of observer would result in increase in frequency. So I can write F equal to F naught into V plus VO by V plus Vs. So this is the apparent frequency when observer is following source. So these are the various possible situations that we can come across when we have this relative motion between source and observer, and in this way I can change the master formula to get the required answer. Now that was about Doppler effect. The next thing that we have is beats. Now beats is the phenomena of getting alternate maximum and minimum intensity of sound due to superposition of two sound waves of slightly different frequency traveling in same direction. So what are beats? Beats are, they are, alternate maximum and minimum. So alternate maximum and minimum intensities of sound. These are called beats. Right. Now how are beats produced? They are produced by superposition of, two sound waves of slightly different frequency. So two sound waves of slightly different frequency traveling in same direction. Right, this is how beats are produced. Now the beat frequency, that is number of beats produced per second, I'll say beat frequency Fp equal to the difference in frequencies of the two waves which are superimposing. Now I'll not get into the derivation of this. So number of beats produced per second is equal to difference in frequency. our our perception that human ears can hear two different sounds clearly if the time gap between them is at least 1/10 of a second. So we cannot hear two different sounds if the time gap between them is less than 1/10 of second. So that will assume, and that will appear to be a continuous sound. So for humans to hear beats clearly, what should happen is the difference in sounds of the two waves should be less than or equal to 10. That means I should not have more than 10 beats per second for me to uh, clearly hear the beats. So we can clearly hear the beats for which range of frequencies if f1 minus f2 is less than 10. So otherwise we cannot hear the beats. Now this is what is beats and how the beats are produced. Now what kind of questions we get based on this beats? The common questions that we get on beats is like various frequencies are given and we are asked to find what is the number of beats. Now the other questions are based on tuning forks. Now we know that what is a tuning fork? Tuning fork is an instrument which produces a specific frequency when disturbed. Now if I file the arms of tuning fork, the frequency produced would increase, and if I wax the arms of the tuning fork, the frequency produced by the tuning fork would be decreased. So this concept, like when I'm filing it, what is happening? The mass per unit length of the tuning fork is decreasing, hence resulting in increase in frequency. And when I'm waxing it, mass per unit length of the tuning fork is increasing, thereby uh, decreasing the frequency of the tuning fork. So questions are, I'll just take one question. Let's say I have a question like two tuning forks when sounded together, when sounded together produce 4 beats per second. So I'm just taking, they produce 4 beats per second. Now if frequency of the first fork, if frequency of the first fork is 250 hertz, and when second fork is waxed, when second fork is waxed, frequency increases to 6, increases to 6, right? Find frequency of the second fork. Let's say this is the question. So how do I do this? What all things are given? Number of beats are 4, frequency of the first is 250 hertz, and when the second fork is waxed, the frequency increases to 6. These are the things given. So let's see how to solve it. I have f1 equal to 250 hertz. Now beat frequency equal to 4 hertz. Now I know f1 minus f2 equal to fp. So from this, f2 is equal to f1 plus or minus fp. So that is equal to 250 plus or minus 4. So I can have plus 4 or minus 4. Now I need to check whether it is plus 4 or minus 4. Now the second condition would help me to check whether it is plus 4 or minus 4. Now what does the second condition say? When the second fork is waxed. So if the second fork is waxed, what will happen? Its frequency will decrease. Of course, slightly decrease. So slight decrease in frequency of the second fork results in increase in number of beats. So if decrease in frequency results in increase in number of beats, that means the initial frequency of the second fork should be less than that of the first fork. I repeat. So what is happening? Because there is a decrease in frequency which is resulting in increase in number of beats. So that is only possible if uh, the if the initial frequency of the second fork is less than the first fork. So uh, once we know that the frequency of the second fork is less than the first fork, then I can write f2 equal to f1 minus fp. that is equal to 250 minus 4, that is equal to 246 Hertz. So this is how we solve questions involving beats. So this is what is there in beats. So what all, and Doppler effect. So let's have a quick review of what all things we have done. We have seen what is Doppler effect. Doppler effect is uh, the apparent change in frequency due to relative motion between source and observer. And we have seen that there is a master formula of Doppler effect, and we need to just check whether the motion of observer or source or both is resulting in the separation decreasing or separation increasing. If it results in decreasing separation, that motion would be responsible for increasing in frequency, and if it results in uh, increase in separation, then that motion would be responsible for decrease in frequency. And after that, we define beats. Beats are maximum and minimum alternately produced maximum and minimum intensities of sound, and these are produced when two similar waves of slightly different frequency superimpose. Hope you could follow this. Thank you very much. Thank you very much for watching this video and all the other videos of Get My Classes. Thank you very much once again.